Hey everybody, this video is a continuation of chapter 2.2. We're going to talk about problems 67 and on, not the applications. We'll do those in yet another video. It's a very long chapter, so we're going to split it up and take a while to cover it. So here in this section on page 131, the directions say, sketch the graph of the function by A, applying the leading coefficient test, B, finding the zeros of the polynomial, C, plotting sufficient solution points, and D, drawing a continuous curve through the points. All right, so I'm going to attempt to do a few of these, and I haven't done them yet, so I may make mistakes. So please let me know after the fact if you see any. And I'll go through each of these things with you. So the idea here, we'll start with 68. The idea is to try to graph these by hand as best as we can. Let's see if I can get that to zoom in a little better. There we go. All right. All right, so g of x is equal to x to the fourth. Turn this off here, get it better. X to the fourth minus 4x squared. Okay. All right, so A, applying the coefficient test. All right. Basically, we're looking at the leading term. And the leading term is whatever is the highest degree. So this is degree 4. So I know this function is going to do something like, let me zoom this in. So it's going to do something like, I don't know, maybe something like this, right? How do I know that? Well, since it has even degree, I know the end behavior is the same on both sides, right? It's either going to rise at some point as x approaches infinity. F of x is also going to approach infinity, and as x approaches negative infinity, f of x will also approach infinity. Or it'll be upside down. That's the coefficient part, right? So the coefficient here is 1, which is positive. So that means it's not going to be flipped upside down, so the arms go up. So like raise both your arms up, that's the way it's going to go. Okay, so that's part A. So part A is determining the end, we call it the end behavior of the graph. Now, these details I don't really know anything about yet. I think that's next, right? So that's part A is the coefficient test. B says find the zeros. Okay, find the zeros. So B is zeros. Okay, so starting off with x to the fourth minus 4x squared, we're going to set that equal to 0 and find out what makes this thing 0. Since both of these have x squared, I'm going to go ahead and factor that out, leaving me with x squared minus 4. And we know that that's a difference of squares, so it will factor 2x plus 2x minus 2. Okay, so I've got 4 factors, x, x. I've got x twice there, so x, x, x plus 2, x plus 2. So I know that x equals 0 for this part, right? Because if x is 0, then it doesn't matter what these are. 0 times that's going to come out to be 0. Okay. And then because x plus 2 is a factor, we know that x minus equals negative 2. That's a 0. And because x minus 2 is a factor, we know that x equals 2 is a 0. All right, so now I can do some details here. I know that this right here is like, those don't really exist. What it's going to do is actually come down, probably bump right there up against 0, because that's a double root or a double 0. The word root and 0 are used interchangeably. Root is usually, and I don't know how defined this word is, root, but I think of it as like where it hits, it's like an x-intercept, right? So a root is an x-intercept of the graph. So it's going to hit right here at -2. It's also going to bump up against 0, and then it's going to pass through again at +2 based on these zeros. Okay, so that's what I think it's going to look like so far. So it's becoming more defined, right? So let's see what else we got to do. C, plot sufficient solution points. Okay. Well, I know this point, I know this point, I know this point. I don't really know this point or this point. And it's very hard to find those without the calculator, but I can find other points on the graph just by picking points and plugging them in. So for instance, I could do, you know, an x and an f of x table, and I could put in, let's say, I don't know, let's go out here to -3. So what happens at -3? Well, if I put -3 in here, I'll have parentheses. Make sure you use parentheses. -3 raised to the 4th power minus 4 times, whoops, that's not right, minus 4 parentheses -3 squared. So I get 45. So at -3, it goes all the way up to 45, right? So that's off the charts here. It's way up there somewhere. At -3 goes up to 45. Okay, -2, I know what happens. It goes to 0. We already found that. And -1, let's see what we get. So that's just going to be -1 raised to the 4th minus 4 times -1 squared. So I get -3. At 0, I already know what happens. I get 0. At 1, let's see. I'm going to get exactly the same thing as I got here, right? Because you're raising these numbers to an even power. So whether that's -1 or 1, you're going to get the same outcome, which is -3. So I know that at 1, I'm down here again at -3, right? So here at -1, I'm down here at -3. And then at +1, I'm down there again at -3. So those should be right across from each other. And then 2, I know what happens. 2, I get 0. And at 3, let's see, what do I get? 3. Well, I'm going to get the same as -3, aren't I? Because both these are even powers, right? So at 3, I'm going to get 45 again. So I can draw a little more detail now. I can do something like this. So we'll do 1, 2, 3, -1, -2, -3. And since I'm going all the way up to 45, I'm going to just count by 5. So that's 1, 2, 3, -1, -2, -3. But then I'm going to count here by 5. So that'll be 5, 10, 15, 20. I'm going to run out of room. 25, 30. I'm going to count by 10s just to make my life easy. So this will be 10, 20, 30, 40, 50, that's high enough. And then down here it would be -10. Okay. So now using my graph here, I know at -3 it goes all the way up to like 45, which is right about there. And at +3, it also goes up to 45. It's very symmetric. At -2, it's 0. And at +2, it's 0. Right? At 1, it's -3, which is, you know, I don't know, right about there. So right where I drew the -1 is where the dot should go. So right about here. And then it's going to bump right there. And then it's going to come down again right here. So it looks something like this. Try to draw as smooth a curve as you can because it is a polynomial. Remember, polynomials are curvy and there's no gaps. So it does something like this. It should be a decent drawing of that graph. Now, you know, let's check it out because I could have made a mistake. So x raised to the 4th power minus 4x squared. And I'm going to make my window. So I'm going to go to my window setting here. And I'm just going to go over to I'll go over to -4 instead of -3, just so you can see a little bit past this, right? -4. X max will go to +4 instead of 3. Counting by ones are the tick marks. All right, X minimum will just go down to -10. That should be fine. And Y max will go up to 50. And those are counting by tens, aren't they? Because I went 10, 20, 30. So if I want it to look the same way as I drew it, then I need to make my window like this. All right, so let's see what this looks like. All right, so it's pretty good. It looks very similar. Twins, as it were. So, and then you can go to your table and you can get those. These are the points we used, right, when I plugged in right here. Those are the same points or coordinates all the way to here. So that's, you know, what you should be able to do. You should be able to graph these by hand and get a decent approximation without using technology. Because you need to be familiar enough with the graphs that you can get a pretty good graph just by doing it without a calculator. All right, so that's how you do these problems. Let's look at one that's a little bit more complicated. We'll do 74 as well. So 74. F of x is equal to -4 x cubed plus 4x squared plus 15x. Okay. So first of all, I want to look at the leading coefficient test, which is looking at in behavior, right? Based on the fact that this is x to the 3rd. That's an odd power. So that means you're going to have one arm up, one arm down, right? But you have a negative, so it's going to be flipped over. So basically, normally, if that was not negative, it would come up from this way, and it would end up going like that. Right? But we're going to flip that over. So I know it's going to actually come down here like this and do something like this. So it's going to have this sort of shape to it right here. I expect it to have 1, 2, as many as 3 zeros. Now, it doesn't have to have 3 zeros. It may only have like 1 0, but it probably will have 3. When I say 1 0, I mean one real 0. It's possible it only crosses the x-axis once. So, but I know it crosses at 0 right out of the gate because every term has an x. So if x is 0, this whole thing goes to 0. So I know that one's right. So that's for sure. To find the zeros, we'll factor it. So we have negative 4x cubed plus 4x squared plus 15x is equal to 0. I can factor out an x, and when I do, that's going to leave me with a quadratic. And I really don't like that negative in front, so I'm going to take it out with the x. So I'm going to factor out a negative x. So that's going to leave me with 4x squared, positive 4x squared, minus, right, because I took out a negative, so that's going to be minus 4x minus 15 equals 0. All right, and this might factor. I have no idea, but there is a, let's see, how do we do that foolproof method of factoring this thing? I think we multiplied the first and the last term, so it'd be 4 times negative 15 is negative 60, right? Now I'm looking for two numbers that multiply to negative 60, but add up to negative 4. So what do I know that gives me negative 60? Gives me 60. I'll worry about the negative part later. So 60, 6 and 10, that'll work because the difference is 4. I'll need the bigger one to be negative because I want them to add to negative 4. So this should be it. So I'm going to replace this middle linear term with these two numbers that add up to negative 4. Okay, so that's the next step. So x, parentheses, 4x squared. I'm going to put the negative first so that I'm not left with a negative in the middle of this thing. You could do it either way, but it's just, you're less likely to make mistakes if you have a negative to go ahead and put it here. And then the next one will be the plus 6x minus 15. So notice that when you add these two up, you get that, right? So I've still got the same value here. Okay, the next step is to group these. So bring down my negative x, and I will group the 4x squared minus 10x, bring down the plus in the middle, and then we group these 6x minus 15. So that's why I put that minus there, so that I wouldn't have to put a minus here, because if the 10 would have been where the 6 is, then that minus would be in the middle, and that I would have to change the signs of these two, and it's just a pain in the butt. All right, and then negative x. Now we're going to factor out what these have in common, which is what, 2x. So we're going to take out a 2x, leaving me with 2x minus 5, yeah? Because 2x times that's 4x squared, and 2x times that is minus 10x. Plus, these two just have a 3 in common. 3 times what is 6? That's 2x, and that's minus 5. All right, so now notice that I've got a 2x minus 5 here, 2x minus 5 here. That's your common factor that you can factor out. Okay, so keep up here. So I'm taking a 2x minus 5 out of this whole thing, and it's just going to leave me with 2x plus 3 when I'm done, right, when I take those away. So when I factor out 2x minus 5, I'm left with 2x plus 3. Okay, so now I've factored That was a lot of work. So now I need to set each factor equal to 0. So we set negative x equal to 0. So x is 0. That's one factor. So that means that, that means it goes through 0, 0 right here. 2x minus 5 is 0. So that's going to be 2x is 5. So x is 5 over 2, which is what? 2.5? So I know that number right there is 2.5. Okay, and then this one, 2x plus 3 equals 0. So 2x is negative 3. So x is negative 3 over 2, which is negative 1.5. So that number right there is negative 1.5. All right, so now I've got the zeros. And then we would like to have some other points as well, right? So making the xy table, xf of x, same thing. And furthest to the left I've got is negative 1.5, so maybe I'll do, I don't know, negative 2. So what do I get when I plug in negative 2? I could just do it this way. I mean, if I factored it right, you could plug in your x here, or you could plug in your x here in the original, either one. So we'll do, I guess to avoid confusion, I'll just go back to the original. All right, so we're going to do negative 2 in the function. And then I'll show you a little trick to make it easier. I'm going to cheat here for a minute. I'm going to put this in the graphing thing. So negative 4x raised to the third plus 4x squared plus 15x, okay? And then notice it's y1, so that's the name of this function, y1, right? So when I plug in negative 2, watch what happens. I get negative 2 raised to the third plus 4 negative 2 squared plus 15 times negative 2. So I get 18, right? Now watch this. Remember, I put that in y1, right? So if you go to, on the calculator, if you go to, where is it? Variables, vars. And you go to y variables. Because we put this in y1, remember? So that's y variables. And then choose function. And then choose y1. Oops, I didn't want to put it there. Doggone it. Let me delete that. Try that again. I want to do this from the home screen. So again, so I press vars. I go over to y vars. I choose function. I choose y1. And then in parentheses, I put what I want to plug in, negative 2. And it gives, ooh, that's not right. Oh, I forgot the negative. Okay, let's try that again. So this time it should give me 18, and it does. All right. So I could plug anything in to that function. Once you enter it into here, it saves that function as y1. So I can simply plug numbers into y1, and it will give me the output, in this case 18. Or if I put in negative 1, so I'll just hit second enter. If you hit second and then enter, it pulls up your old one. I'll just change that to a 1. That's negative 7. We know 0 already. 0 is 0. We discussed that. If I plug in 1, just go over here and delete that negative. I get 15. If I plug in 2, I get 14. And I'll plug in 3. And I get negative 27. All right, so let's put it all together and make this graph a little bit prettier. I know what looks generally like this. I know where it hits the x-axis, and I've got some other points here I'm going to plot. So it goes all the way up to down to negative 27 and all the way up to 18. So I'm going to, and it doesn't go very far left and right, so it's like kind of like this. So 1, 2, 3. Negative 1, negative 2 is as far as I went that way. Let's start with the zeros. I know at 0 it hits 0. I know that at 2.5, so 1, 2 and a half, it hits 0 again. And I know that at negative 1.5, so here's negative 1, here's negative 1.5, it hits 0 again. So there's 3 points. Okay. At negative 2, it goes up to 18. So I'm going to count by 5s here. So that would be 5, 10, 15, 20. So at negative 2, it goes up to almost to 20. So we're somewhere right about there. At negative 1, it goes, here's negative 5, here's negative 10. Right, so at negative 1, it goes down to negative 7, which is right about there, I guess. 0 goes up to 0. 1, it goes up to 15. So at 1, it goes up to 15, so it's right about there. 2, it goes to 14, which is almost the same as 15. And then negative 3 goes all the way down to negative 27. So there's negative 15, negative 20, negative 25. So at 3, it goes way down here, a little bit past 25. So what I've got is, I know it looks like this. Up goes through. That's the general shape. So starting here, I come down, I pass through the x-axis. I hit this. It looks like a minimum. That might not be the minimum, but it's close, probably. It goes up. It comes up through here. It passes through 15, and then it must curve and come back down, passing again through this 0, and then going this way. So that's what the graph should look like. Let's see if it's, I already put it in there, so we'll hit graph. Now if I want my graph to look like this graph, I'll go to my window settings. So my x minimum should be like 1 to negative 2. My x max should be 3. My scale is 1 because I'm counting by 1, 2, 3. My x minimum should be like, I'm going to put it at negative 30. My x max is like 20. And I'm counting by 5s. All right, so hopefully this will look very similar. Right, and it does. I mean, it's more spread out because I spread this x-axis out so much. If I wanted to squish it together, I could just go in here and, like, I don't know, for my y minimum, I could double that to like negative 4, and I could double that to 6, and then it should look a little closer to what I've got. Okay, so that's how you do these problems. On this page, it's 131 starting at 67 through here. very time consuming. It's a lot to do. Remind me in class, and I won't assign very many, but you need to do a couple, maybe 3 or 4. All right, so then here, what are you doing? Using a graphing utility to graph the function, use the zero or root feature to approximate the zero. So determine the multiplicity of the zeros. So here you're just graphing it on your calculator and you're determining the multiplicity of zeros, and this should not be a big deal. I'm not going to waste your time going over this. Since you can, I know most of you, hopefully all of you, can put this in your calculator and graph it and transcribe that onto your paper. What's this? The intermediate value theorem. Use the intermediate value theorem and the table feature of the graphing utility to find intervals 1 unit in length in which the polynomial function is guaranteed to have a zero. Adjust the table to approximate the zeros of the function. Use the zero or root feature of a graphing utility to verify your results. So let's do one of these. So I'll do 88. This is all calculator. So problem 88, let's see, that's x to the 4th minus 10x squared plus 3. Okay, I'll just hit a zoom 6 for a standard viewing window. See what it looks like. Okay, so in this function, there are no real zeros, right? There are no real zeros. Therefore, the intermediate value theorem, at least the way they want us to use it, doesn't even apply. So it never touches the x-axis. That means all 4 zeros of this function, since this is x to the 4th, are all imaginary. All right, so let's try a different one. Let's look at 86. I'm starting to doubt myself, so let me just graph that again. I feel like maybe I did something wrong. I'm surprised they would do that, but they might. So minus 10x squared plus 3. I did mess up. Messed up big time. I'm glad I checked myself on that. Okay. I don't know. I don't even remember what I did. I just remember there were parentheses where they shouldn't have been. Okay. So let's read the directions again. Use the intermediate value theorem and the table feature of your calculator to find intervals in which the polynomial function is guaranteed to have a zero. Okay, so that means I'm going to go to second graph and look at my table. So basically what the intermediate value theorem says with polynomials, that where it's really most useful is right here, where your y value I'll go up to here. Notice your y value is very big. You go down, it's getting smaller. You go down, it's getting smaller. But it's still positive, right? It's positive 99. And then here you just hit a negative. So what that means is, since it went from positive to negative, you must have crossed the x-axis. Where did you cross the x-axis? Somewhere between -3 and -4, right? That's what the intermediate value theorem basically says. Between these two numbers, there must be a number that corresponds to a number between these two numbers, right? And the one we're really interested in is when this is 0. At some point, it went from 99 to -6. At some point, it hit 0. Where did it hit 0? Somewhere between -3 and -4. So I know that between -3 and -4, I have a 0, right? So for problem, what problem is this? 88. I know that I have a 0 I'll just use z for 0, is somewhere between -3 and -4. It's bigger than -4, it's less than -3, based on the fact that it went from positive to negative. Okay, now it's negative, 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 and then from negative to positive, so there's another 0, right? There's another 0 between -1 and 0. So between -1 and 0 is another 0. All right. And then again. So here it went from negative to positive. Now it's going from positive to negative. So I know between 0 and 1, there's a 0. And again, between 3 and 4, because it went from negative to positive. So between 3 and 4, there's another 0. And then I think it's just going to get bigger. It goes to infinity after that. Now, if we hit the graph, we can see that this is true. You can see that right here. It looks like I have a 0 between -3 and -4. And then I've got another 0 right between 0 and 1. Let me blow that up. And then I've got another 0 between, sorry, there's a 0 here between 0 and -1. And then another one between 0 and 1. And then another one between 3 and 4. And then the last thing it says is, well, estimate those using your calculator 0 function. So we would go to second trace 0. And I'll start on the left. All right, so there's left of that 0, and then there's right of that 0, and then enter. So that's about, according to this, I don't know if you could read that, but that's about -3.11. Is an that's the one that's between -3 and -4. Okay, and then we'll do it again and try to find this 0 here. So second trace 0. All right, go to the right, where I'm just to the left of it. That's good enough. And then move to the right. That's good enough. Enter. -0.56 is a good estimate. -0.56. Okay, and then we'll do it again. It looks very symmetric, so my guess is it's going to be positive 0.56. So there's left, there's right, and it is positive 0.56. And this one's going to be 3.11. Let me do it just to be absolutely sure. Oh, all right, so there's left, there's right, 3.11. All right, so that should finish up this video, and then we will do one more on applications of polynomials. We already did one in lesson 1. We did the box thing, but we'll practice doing some more of that. All right, so thank you so much for watching, and good luck on your homework, and we'll see you soon. God bless you guys.